morning, developers. If you are new to the channel, my name is Rob, and it is CS Thursday, the day that we focus on how stuff works rather than on implementation details. And today I want to look at these three concepts. The how are they different, but then the benefits and the negatives of each one. Synchronous programming, asynchronous programming, and multi-threaded. And how are they related, and where are they overlapping? Because depending on where you're coming from, you may have no idea what any of them are. You may have some notion, you may have intimate knowledge, or maybe you know how they all work, you just want to hear how somebody else defines it. And I've always preferred, I guess, a particular illustration to communicate this, to teach how they work. And so we'll start with synchronous because it's definitely the simplest. Synchronous programming, I'm going to put up here. Almost everybody has been in this situation. You are at the grocery store. Okay, whether you have a cart full of stuff or whether you just have a bottle of soda and you're walking up to the front of the store where you want to go to the cashier, there is a person who is going to check you out. And there is usually some kind of line, or at least there's a possibility that there's a line. Maybe there's not. Again, very common situation that's easy to understand. Synchronous programming is going to work exactly like this, where we have a single line, and however many people are in it, and you have to wait your turn, okay? Blocking is the word that we use for your code. It is blocking in this case because maybe you've been in this situation before. The analogy breaks down a little bit at some point, but you'll get the idea. You only have a bottle of soda, okay? It's maybe it's late at night, or you've got one thing in your hand, a bottle of soda, we'll say. And you are walking up to the cashier, and there is a sweet elderly woman who has a cart that's completely full. It's overflowing with stuff. And no matter what you do, if you sprint all out and dive head first, you will not be able to get there before she does. And you are going to have to wait a really long time for her to finish checking out, even though you only have one thing. And you're thinking, could I just slip mine in there quick? You know, it'll only take a few seconds. I've got a credit card. I'll be out of here in less than 5 seconds, whereas you're going to be here for 15 minutes. But that's not how it works. That is synchronous, and that is blocking. The negatives are obvious, right? Like I just said, if you have something that's going to take a long time to run, you have to wait, okay? That makes it difficult to scale. That makes it difficult to have a good user experience because you might have a button that's waiting to be clicked on and nothing else can happen until it gets clicked on. Maybe you have a process that's waiting for a disk write or a disk read, or you have a server that's making a database request. You have to wait until that line finishes, right? Line 1 runs and then line 2 runs. And however long line 1 takes, right? This elderly woman, however long it takes to check her out, well, you're just going to have to wait, okay? The positive, though, about synchronous programming is that it is so simple, okay? It is blocking, but I'm going to put up here blocking equals simple to understand. This is how most people right up front are going to assume that programming languages work. When you write a line of code, you expect it to come first, and then line 2 you expect to come second, okay? That's convenient because it is simple to implement. It's also simple to troubleshoot, right? That's always a win. If you have a bug or an error message, you'll usually be able to figure out what it is much faster if you have blocking synchronous code. Most programming languages work this way out of the box, okay? They almost all have the ability to be asynchronous or multi-threaded. In fact, I don't know hardly any other than JavaScript is I cannot think of a scenario where it's ever going to be synchronous without some serious library work. That's just not how the language is organized. JavaScript and Node.js. Okay, so we'll skip on to the next illustration. Asynchronous is a little bit bigger topic because it just communicates that it's maybe non-blocking, so that you can run multiple things at a time. But asynchronous, I've got an illustration here. Maybe you still only have one cashier, but you've got everybody bunched up around the countertop or the conveyor belt. And whoever puts their thing on first gets to go. So maybe somebody showed up and they're in line ahead of you and they have a huge bag of dog food. Or maybe they've got like 15 huge crates of water and they're going to have to set them all on top of the counter. And the cashier is just going to wait for them to do it, okay? That's the problem with blocking. That's what we want to get away from, the synchronous code. We want to be able to, hey, you're not ready, but this person behind you is ready, so let me run them. Again, you've got the person with a huge cart full of stuff. While they're unloading their cart, you can quick say, hey, let me run my bottle of soda through, and you're out of there before they're even halfway done. All right? That is going to be non-blocking. At least that's how I am sort of defining asynchronous at the moment. The easiest example of this, as I said, is JavaScript. JavaScript uses a callback system, meaning line 1 runs, and then it will always run the very next line that it can, always. Okay, so it still runs in a synchronous fashion until it gets to a line that it has to wait for something. So maybe in JavaScript, you're waiting for a user click. Well, it will skip over top of the callback. It will keep running code, and then when that click happens, it will call the program back to run that code. Likewise, in Node.js, maybe you have a database request and you're going to fetch something from the database or from an API or whatever. You have to wait for that the database is doing its thing. Or you're writing a file. Well, the hard disk has to do its thing, or your SSD or whatever. While that's going on, JavaScript can, back to our illustration here, it can process somebody else. Somebody else is ready while you're getting your big bag of dog food up on the countertop. Okay? So that is asynchronous in the non-blocking sense. Another sort of subset of async, if you want to think about it like that, but really I'm treating them different, non-blocking versus multi-threaded. Multi-threaded, we have another illustration here where we have a whole bunch of cashiers. Okay, so instead of just one line, right, this is a big store and you've got 3 cashiers. So if there's a family in front of you with a couple kids and a shopping cart that's completely bursting with stuff and all you've got is your one soda, go to a different line, right? Pick the line that doesn't have anybody in it or has somebody in it that's not going to take much longer. So maybe all of the lines are full, and you've been to a store too before probably where, all of a sudden you see somebody waving and, oh, that line's open. Okay, that is how multi-threaded works. Now let me draw out here real quick. Your CPU, the way that it works, if you've seen one before, you probably have, it's usually a little square piece of metal that's just really expensive. Almost all modern CPUs have more than one core. They're multi-core, and that's usually how they're marketed. So let's say, just to make this easy, this is a 4-core processor. A core is actually made up of 2 individual threads. So I'm going to put like a slash there to demonstrate, right? This core has 2 threads, same here, same here, same here. Each thread is capable of running a command, of executing some computational power. And so multi-threading is able to take advantage of all of that stuff. So again, a 4-core system would have 8 threads. You could have a task running here. You could have a task running here. Right? Another task comes along, it doesn't have to wait in line, it can grab this one, etc. Right? Once they're all filled up, you can have a pool of threads and you can grab from, just like I said, the cashier waves at you, hey, I'm free now, and you can go hop in line. Okay? The advantages and the disadvantages of these two, and again, I kind of grouped them together because depending on how you want to think about it, multi-threaded is a kind of asynchronous programming because you can run code at the same time just on different threads. In the JavaScript or Node.js example that's non-blocking, and virtually, I would say most languages have the ability to do non-blocking. Python, you can do it, it just requires a library. Java, same way. C#, same way. Most languages can do that. JavaScript's the one that comes out of the box like that. The advantages of non-blocking asynchronous programming is pretty much all of the negatives of blocking or synchronous, right? These are almost exactly the opposite. Non-blocking is able to scale and has a really nice UX. The downside is it's not nearly as simple to understand. In fact, most people when they start programming in JavaScript, it is really confusing trying to make sense out of how this works. Why are these lines running out of order? And I'll put back up here debug. JavaScript can be really frustrating to debug. Python, if you're doing async, etc., because the line that actually causes the error a lot of times isn't the line that is causing the trouble, or things happen, again, out of order, and that's difficult for how people think. Multi-threading is going to be similar. It can also scale exceptionally well because you can use all the power that the processor has. So the scale possibilities are much greater because you can grab all of the processor. The downside is that maybe unlike the other two, it is even more difficult to write well. It is exceptionally powerful if done correctly, but if you're an individual trying to do multi-threaded, in say C# or something like that, maybe in Python, it can end up locking your computer or locking the user, locking the end product, because you've got threads that are competing with each other for processes, or they need the same data or whatever, and threads get locked out. So it's difficult to do well, but if done well, it has the potential to take your machine the farthest. Again, the more cashiers you have at the front of the store, the happier your customers usually will be, because they won't have to wait and they won't have to compete to try and get something on the island or the countertop. Most languages support multi-threading, the exceptions being JavaScript and Node. You cannot program in a multi-threaded fashion. PHP and R are three examples that do not allow multi-threaded programming. Now, a fourth example, which is how you would do these things in, say, JavaScript. You can do them like this in Python or Java as well, but I'll put another one up here. Let's say you still have one cashier, right? So you still have one application, but now your cashier has a whole bunch of arms, okay? I don't know if this is a perfect illustration or not. With Node.js, using the cluster module, you are able to run the same program on multiple threads, so that it will take advantage of the CPU power, but you still have some control over what's doing what. So this would be really common if you have a really high powered application that is very, very demanding. You can source a whole bunch of the same task out, so everybody is running the same code. Okay, unlike true multi-threading, where you can have completely separate code, separate tasks, even applications running on the different threads. In Node, or other languages can do this as well, but using the cluster module in Node.js will allow you to run the same code on all of the different threads and coordinate how they all interact with one another. Okay, so this is sort of the fourth possibility, where you have a kind of hybrid between multi-threading and the non-blocking asynchronous approach that JavaScript takes. Okay, so real quick review. The grocery store example. Everybody has gone to a grocery store probably at some point. And the typical approach, or the simplest to understand, is the synchronous one. And that's, you've got one line, and you just have to wait in line until the person in front of you is done. In programming, right, line 1 runs, and then line 2 runs, and however long line 1 takes, well, line 2 has to wait. It's awesome because it's simple, right? It's very, very easy to understand. It's easy to debug, and so on. The problem is that this is a scaling nightmare. You have a really hard time. Again, if you're that person who all you have is just a bottle of soda, you have to wait 5 people in line, and it would be nice to be able to go faster. This also creates like a bad UX, a user experience, because if you have a button that can't be pressed until something else finishes, that's bad. The second example is if you have everyone huddles around the island and you just put your thing up there when you're ready to go. So you don't have to wait for anybody else. If you're ready and there's an opening, or the processor, the cashier is waiting, you can go. This is great because it allows you to scale better. It gives for a better user experience, right? It's pretty much just the opposite of blocking program. Again, I'm talking about asynchronous there in more in the sense of non-blocking concurrency. The third example, multi-threaded, is going to be like you have multiple cashiers, lots of opportunities of where you want to check out. If they're all filled up, usually there's some cashier will wave at you when they are ready. That is awesome because it can take full advantage of the processing power that you've got, which means you can scale well. The problem with it is that it's usually really difficult to do well, can get really confusing, and it actually can cause some locking problems if you get into trouble. There are a few languages that simply do not support this, at least to the best of my knowledge as the making of this video. Our fourth example is if you have a single cashier, but he's got lots of arms, right? So like in the case, again, of Node.js, you run the same code or the same application on a bunch of different threads, but they coordinate together. So somebody shows up, the cashier is able to keep processing the same person in the same order, but with another arm, they're able to pass you through, and they've got maybe 4 other arms passing a whole bunch of other people along. So that's kind of the hybrid model that some of the async or the non-blocking can take. You can run the same program, do the same thing in Python and Java and so on. So that pretty much does it for this video. Even though there's always more to say, these are big topics. We maybe will come back and treat them in a future video. But thanks so much for watching. I'll link another CS Thursday video, and I will see you next time.